there. So the next question I have for you is based on your slides there. And correct me if I'm wrong, you showed Mount St. Helens, the eruption. These newly formed rocks were dated and they were given incorrect ages, millions of years, but those rocks were literally just formed, which is why I like to ask the critic, why should we trust the dates you're giving us from rocks of unknown age deep within the rock strata when you can't even give us accurate dates from rocks of known age? But what some of the critics will say, Sal, in response to this, I think it's basically just a rescue device. I'm curious to what you think. But a lot of them, they'll say, well, don't you know, creationists, you're not supposed to date rocks that are just formed, because then you're going to get erroneous dates. You have to wait tens of thousands to hundreds of thousands of years before you can date them in the first place, Sal.
Well, that's pretty much circular reasoning, isn't it? You know, we can't get the right dates from rocks of known age, of relatively recent age. We can't get the correct dates from radioisotope dates. So they automatically say, oh, yeah, well, you can't get it until the rock is 100 million years old, or you know, that's just an ad hoc excuse and given to cover up the fact that the isotope dating does not work on samples of known age. Now it's not that the AMS labs cannot detect a small amount of the ratio of these isotopes. They can. It's not the fault of the labs. These labs are very accurate in being able to detect the amount of these isotopes and their decay products. They're very accurate. But the fact is that what they do detect, the age that they get in most cases does not agree with the various isotope methods that you use, the various clocks that you use, nor does it agree in many cases with the expected evolutionary time of the sample. So they have to keep going around through the dating game, changing parameters until they get a date that they like. As I have shown you tonight from published reports of this, I must have gave you at least a half a dozen examples from published reports of the dating game. And the fact that the isotope form requires or is highly suggested that you put the date that you're looking for on the form.
That's right, Sal. And so you said at the beginning of your answer that it is circular reasoning. So let's assume the Earth is 6,000 years, which we believe and you've demonstrated is true. So what do we do then? If the Earth is 6,000 years, but we have to wait 100,000 years to date these rocks, does that mean we just can't do it then? Apparently we can't test the method then, right, Sal?
Well, we can't touch them until we get a date that they like.
Right. Yeah, it's circular reasoning. Well,
I showed you that from the dating of the fossils in the geologic column. You know, that it's a dating game, and that the published results follow the expected results. The published results do not proceed and then tag the sample itself. The sample is decided ahead of time as to where it fits in the evolutionary scheme of things, and the published and the measured results from the isotopes better agree with it. If it doesn't, they'll do something to go around and round and round until they get a date.
Yeah, so I'm wondering your thoughts, because sometimes, Sal, you'll hear them say, well, we have achieved or obtained correct dates. One that they'll look to, and even before I say it, I like to say, well, the exception doesn't overturn the rule. So the rule seems to be inaccurate dates. If you can show us one that you seem to have gotten right, okay, that doesn't overrule the rule. And a broken clock is right twice a day. Anyways, they'll look to Mount Vesuvius, which I believe erupted in 79 AD, they say, 5 miles or so from Pompeii, famous story there. And they say, well, they dated those rocks, if I remember their argument correctly, and we got the right date, they'll say. And so dating methods must work. Sal, what would be your preferred
What we
response
show
to that?
from the published dates is that not creationist dates, but published dates, is that in most cases, many cases, the dates are from the same sample. In other words, you take multiple samples from the same rock strata you're trying to date, and they don't agree with each other. Right then and there, they don't agree. Then, okay, they take a different method, a different clock, a radioisotope clock to date it, and that doesn't agree with the first set. Okay, and then none of those agree with the expected date. That is the rule. That is the rule. Now, like you said, you may have an exception. They happen to come out with a date that seems to work on the first try, 1 or 2 tries, but that's the exception. The rule is that most of all of those dates are not published if they do not agree with the expected ideology of Darwinian evolution.
Yeah, I think that's a great response. So their next argument would be, Sal, well, okay, if dating methods don't work and the Earth isn't billions of years old, and we're just supposed to throw away radioisotope dating, they'll say, why, the deeper you go in the geological rock layers, why do the lower rocks end up dating older than the rocks that we find either closer to the top or at the top?
I was going to explain some of that to you, why we find that, and it is true. Using these isotope dating, there seems to be a roughly relative date order in which the deeper and lower rocks, like the Precambrian rocks, will date older than the Phanerozoic rocks. See, and so that's true. That's true. There is a somewhat of a correlation there, but there's a reason for that, and extensive studies have been done. And I don't have the time to go into that all tonight. I have the slides and everything for that, and their references. But basically, what we found is that in the past of the Earth, during the creation week, there was no doubt an accelerated radioactive decay rate, accelerated fission rate, and also there was somewhat of an accelerated rate during the rocks that were intruded into the Phanerozoic column, that is the later fossil-bearing rocks that date at only about 500,000 years old, 500 million years old. And so because that accelerated decay over accelerated the decay, when we sample a rock, it appears to be very old. And the lower down in the column, that accelerated decay was going on for a longer period of time. After the flood, the accelerated decay was only for a shorter period of time. So those rocks, when we measure the ratio of parent to daughter isotopes, we get an apparent age of, like in the tens to hundreds of millions of years old. So there is a relative age of some of these rocks that is there, but it's only apparent because we believe in the past there were several periods of accelerated decay. And is that arm waving? No. There's experimental evidence that points to that and basically verifies that that in the past, the notion that the decay rate has been constant for so-called millions of years is not a reasonable assumption to make, because it doesn't appear, it appears that there are factors that affect radioactive fission in these unstable isotopes, and that the decay rate cannot be assumed to be constant over so-called millions of years.
So basically, if I understand correctly, then during the flood, is that when you would argue the most accelerated decay occurred? So would be during the flood?
No, there was a period during the creation week,
Okay,
when the various when from the initial elements, as shown, as indicated in Scripture, God formed the various foundations of the earth, which was known as the lithosphere, the mantle, the outer core, the inner core. When these were formed from the initial elements of the earth, there was a period of accelerated decay after the fall, probably occurred after the fall of man. And as a result of the corruption of the earth, there was a period of accelerated decay. And then during the post-flood, there was a secondary period of accelerated decay that didn't last quite as long. And that's why the samples appear to have an older date, but not quite as old as the rocks from the initial creation rocks and the Precambrian rocks.
Okay, so basically your lower rocks would have experienced more rounds of accelerated decay as the rocks were being laid down or formed till you get to the top. So then those would be dated younger, essentially, Sal?
Yeah.
So I've got some people in the chat, especially the critics, saying, oh, what's the evidence? Well, I'll say that a line of evidence for accelerated decay that I've always found to be fascinating, Sal, is the helium that they find in zircon crystals, the abundance of helium, because as we know, uranium decays into lead and it gives off helium atoms. But helium's a very slippery molecule from my understanding. And so if these zircon crystals were really billions of years old, then all of that helium should have dissipated into the air. It shouldn't be there. But the fact that we do find the helium, but also uranium to lead, we find enough to know that decay has happened. That decay must have happened rapidly in order for that helium to still be there, Sal.
Yeah, that's correct. And that's based on empirical measurements of the rate of which helium will dissipate through those crystals. It's not arm waving. They've done quite a few experiments to test the rate at which helium dissipates through those zircon crystals down in the granite. And so there's that line of evidence. The other line of evidence is the fission tracks that we see and the radio halos that we find in crystals of granitic type rocks. Those radio halos indicate that there must have been periods of accelerated decay for them to form. And without going into the weeds and all the details of that, that's a whole study in itself. But those radio halos, along with fission tracks, along with the helium dissipation in the zircon crystals, point. It's not absolute proof, but it does point to a reasonable explanation of why the isotope dating tends. There's many exceptions to it, but it tends to indicate that the lower rocks are older than the younger rocks near the upper crust of the lithosphere. But the only problem with that is that there are so many discordant dates that when they date these rocks that don't agree with each other, that it's hard to sort it out, because this none of the radioisotope dates are consistently agreeing with each other.
Right.
And so you don't know which one is correct and which one isn't correct. So you can't really use it as a dating method. And so it's hard to sort out why exactly the upper rocks have a little bit younger age than the older rocks. But we could be pretty sure that you can't use it to determine an absolute age.
Yeah, I think you nailed it. Accelerated nuclear decay is interesting. Discussing these points of evidence like radio halos, fission tracks, and helium. Again, helium for the audience. Helium diffusion rates are so rapid that if the helium was being released into the atmosphere over billions of years, with the rate that we understand helium diffuses at, there shouldn't be any. So how do they explain that? But the point you're making is dating methods in general are unreliable. Too many discordant dates. We've even got questions on isochron from the critics. Well, how do you deal with these isochron plots? But I've looked into that, and I've seen papers from Dr. Andrew Snelling showing false isochrons, discordant dates, even with their praised isochron method. So it does seem, Sal, that dating methods in general are not reliable in giving us absolute ages. Maybe relative, if I understood you correctly, but not absolute.
You might get a somewhat of a relative age, but you again, you can't know which whenever you test it, whether that age you're getting is correct or not.
Right.
Because
right.
they're just unreliable. You know, within the same samples, you'll get a huge difference. It's like I said, when you go to the carnival and the guy says, well, yeah, you're between 1 month old and 99 years old.
Right.
So I did guess it right, didn't I? I did guess your age, right? I put you in the right category, okay?
Yeah.
And so it's like there's so much discrepancy between these ages of orders of magnitude of discrepancy. In other words, the differences in the ages from the different testing could be 100% off, 1,000% off, 10,000% off. I mean, it's ridiculous. You know, it's like to say, well, you're between 30 years old and 900 years old. Well, yeah. Can you tell me my age?
Exactly. As if we're supposed to be impressed. Yeah, you're right. Somewhere between 30 and 500. And that is very similar. That is analogous to the way that they present these dates that they get, Sal. And that's great. Yeah, it's not empirical. And I wonder.
Isochron method
Yeah.
has been shown over and over again. I was going to do that tonight, but we just don't have all the time to do that. But the Isochron method has the same error ranges and inconsistencies as the traditional radioisotope model, they call it, where the parent fissions and goes through a process where it produces a daughter product. But the Isochron method has the same deficiencies. They appear to plot theoretically the same. If you look at the math, it looks good. It looks good on paper. I mean, you know, the math looks good. But the open system of the Earth is so much more complex that the mathematics can't completely describe the process. So again, you have inconsistent results in the samples. I sometimes give an example of this. It's not so much that the math is not correct, but it's not. Math is a language, and it's not able to reproduce all the variables in the open system of the Earth. When we have pilots, I explain to them how the lift on an aircraft wing can be mathematically described. It's proportional to the dynamic pressure, which is 1/2 rho v square, 1/2 the density of the air times the true airspeed of the aircraft. It's proportional to that and the angle of attack of the wing, the angle at which it hits the air. And you could mathematically come up with an expression and solve that. And so you get, okay, this wing is going to produce 300 pounds of lift per square foot or something like that. You come out mathematically, it looks good. It's actually correct. But then you put the wing in the real world of the chamber, the wind tunnel, and you measure it, and it's not 300 pounds. It's 600 pounds. It's way off. It's way off. In other words, the mathematics cannot describe exactly what's happening in the real world. So what they do is they test the wing at various angles of attack to the airflow and various speeds of the air, and they come up with a coefficient of lift. Now, that's a fancy term for a fudge factor. It's a number that you multiply the mathematical expression by to get the real answer that you find in the wind tunnel. Well, now, we could get the real answer in the wind tunnel. You can't do that with a sample, dating a sample. We don't know what the real answer is. But in engineering, you could apply a fudge factor, a coefficient, if you have a way of testing it and getting the real answer. But in the real world of trying to date a sample, we don't have any multiplication fudge factors. The mathematics cannot handle all the variables in an open dynamic system. So that's why we get all these discordant dates and all, but we have no way of correcting them because we don't know the real answer. Right. We can't put a sample in a wind tunnel and tell us what the age is,
And apparently we can't date the rocks until 10,000 or more years later. So you're right. We don't actually know the answer in order to.
So there's no, in the field of engineering, you could become very precise because you could measure the results and control the factors of what you are experimenting with. But you can't do that in the open system of the Earth. The sample is not locked in a lead-lined container with a steel shell around it, as I had shown in the slide. It simply isn't, and it's foolish to think that all the mathematics which applies to the closed system, When I was a graduate student, on a box, on a piece of paper, okay, and it's called a model or a closed system. And they showed us what the mathematics was. I briefly showed you the term for dating, isotopic dating. And being an engineer, a previous engineer, I was pretty good at math. I'm probably, more versed than most of the geology students there. And I could whiz through those mathematical models and come up with a date, and everybody goes, wow, Sal is pretty smart, he could figure out those answers. But they never told me in graduate school that box that represented a sample is a box inside a safe buried in the ground. It's not equivalent to the real world open system. I didn't know that till I started studying this creation literature and information, for years. So the mathematics will work on a model that you draw a box around on a closed system on a piece of paper, but it doesn't necessarily at all work in the real world.
Excellent points. Sal, this has been so good. And